I want to illustrate the method of using decomposition by function to help you in exploration. I want to do it by using the ice cream scoop example, and you may recall from the problem definition video that we came up with the problem statement: in what way might we create a better handheld tool for forming balls of ice cream from a bulk container? Now, decomposition by function is facilitated by the creation of what I call a function diagram. And a function diagram is basically a flow chart that describes what it is that the artifact has to do and can be thought of as functions involving the flow of materials, energy, and signal. And so let me just illustrate with the ice cream scoop. I think the flow of material is the most straightforward. So let's imagine we have the bulk container, which has the ice cream, and then we have a can imagine dividing some element of that, some portion of that bulk, and then we could imagine forming that portion into a ball. And so the first, if you want to think about it functionally, the first thing that happens here is an ice cream scoop divides from bulk. So it takes the bulk ice cream and it divides it from the bulk. And then the second thing you might imagine an ice cream scoop doing is forming a ball. And so the flow of materials in this case can be thought of as two steps: dividing from bulk and forming a ball. And in terms of flow of material, that's what an ice cream scoop does. Now there's also a flow of energy, and the main energy flow in an ice cream scoop is apply human power or human force. You can think about that as a flow of energy from our user. And there might even be some signal, but there isn't always a signal flow. You might imagine some kind of signal, which is, is it a nice portion? And that flow goes back to the user. All right, so let me first emphasize that function diagrams are not unique. That is, there are many possible ways of decomposing what it is an artifact does by function. This is a reasonable way to do it. I think it's very useful to think, for most artifacts, to think about the flow of material, the flow of energy or force, and the flow of signal. And that lets you think about what are the elements, the fundamental elements of function that device performs. Now this is a very simple artifact, an ice cream scoop, but even for a very simple artifact, it is possible to decompose or break down what it is that artifact does into smaller pieces. The next step in using a function diagram, so this thing we call a function diagram, and the next step in actually using the function diagram for exploration is to pick typically at most 2 or 3 of these functions to use as a way to focus your exploration effort. And as I look at this, I think really the obvious ones are clearly the way in which the scoop divides from bulk is going to be critical. It's going to be critical to think about the application of human power, and maybe there's some interesting things that could be done as a result of focusing on the forming of the ball. But I think for now, I'm going to focus on these two, the application of human power and the dividing of a portion of ice cream from bulk. All right, so let me show you how that works. So we're going to divide our design problem into just two pieces, and the pieces are going to be divide from bulk and apply human power. And remember, the key idea in decomposition is we're going to focus single-mindedly on that subproblem and not necessarily in the context of the overall design problem we're trying to solve. So for instance, let me just give some examples for how we might how we might use that decomposition by focusing on applying human power. So some ways that you might apply human power: you might imagine twisting. You might imagine squeezing. You might imagine hammering or impacting. Let's just draw a little hammer here. You might imagine, I don't know, pushing. You might imagine pulling. A little handle here. You might imagine, I don't know, let's imagine even, as crazy as this might seem, stepping on something. We might imagine, and I guess it's a version of squeezing, but I'm thinking about like the shears that are used in cutting branches that look like something like that. And that's kind of a squeeze as well. All right, now see what we just did there. We generated a bunch of ideas for how it is that human power can be applied. None of these in the context of ice cream scoops, but just generally, how is it that human power is applied? And you know, to illustrate that it really should be outside of the context of ice cream scoops. You can even imagine, you know, pedaling, right? It might be an application of human power. So those are all the ways you might apply human power, or many of the ways you might apply human power. Okay, so now let's do the same thing over dividing from bulk. What are ways that things are divided from bulk? I don't know, you might imagine a bulk sheet of material and imagine that it's perforated, and so I'm going to call that pre-divided, and break maybe. Actually, breaking generally is an idea. Breaking, or I suppose let's see how we're going to break this out. break, or tear. We might imagine, let's see, oh, I like, how about this? How about punch? Punch. There are certainly, what about just cut? You might imagine a cutter of some kind. Yeah, you get the idea. Let's imagine there could be, oh, how about like the way you think about the way an excavator works. An excavator shovel has a claw on it, and a big arm and an actuator, and we could call that excavator. Scoop. And let's see, how about carve or shave? We have some kind of blade that gets pulled along, and that causes a carving or shaving of a curl of something. Carve, shave. And, you know, some of this is challenging to sketch, I realize, and so, you know, annotation is usually very helpful in helping to illustrate what it is you're trying to get at. Okay, so basically we've divided, we've decomposed by function, we've picked two functions, and then we've generated two functions, and then we've generated some solutions to subproblems that are independent of the particular ice cream scoop problem. All right, now's the fun part, which is we pick one from column A, one from column B, and we see if we can create an ice cream scoop that integrates those two principles. So let me take, let's take this guy, punch, and twist, and see what we could do. So we're going to do a punch and twist. So imagine you had a scoop. Let's see if I can get this right. So imagine so what if you had a cylindrical yeah, let's see if I can get this drawing to be a little better here. All right, so what this thing is we're going to push on this thing, and this is so now if I look at the bottom view of this thing, it's a cylindrical section that is like a cookie cutter, all right, that can punch out. And so the way you'd use this is you'd press this cylindrical cutter down into the ice cream, and then you'd put your thumb right there, and you'd use it to twist the cutter to form a cylindrical plug of ice cream. All right, so everyone see what we just did there. we took the idea of pushing to cut, punching to cut, and twisting to cut, integrated into the solution. That's the idea of cutting a cylindrical plug and then twisting it to cut. All right. How about one of the things that's kind of frustrating about ice cream is getting leverage on the ice cream itself. So I like the idea of, if we go back here, I'm intrigued by this idea of squeezing, and I wonder if there's a squeeze and a scoop that we could do. We should have just a scoop here, right? A squeeze and a scoop so could there be an ice cream scoop that has, let me think how this would work. It would be like a shear of some kind, and let's see, it's going to have a jaw that comes this way as well, and you're going to put it in the ice cream, and this thing is going to come down. So it's a pincer scooper. So this leverages the idea of using opposing force of squeezing pincers instead of requiring the wrist of the user to resist the action of the scooping. I'm also intrigued by, here's another one that I'm intrigued by. I wonder if there's more of a pulling action that we could use. So you could imagine the user grabbing this thing and pulling, and if we could somehow get the cutter, the pulling feature part of this thing, so this is going to be pull to form a curl of ice cream, then that also would have this nice quality of all the forces lining up so that it doesn't hurt the wrist. All right, and let's see if there's another one here. I wonder if there's a way to kind of do the excavator thing. I'm thinking, so a push approach, and let's imagine we have a ball-shaped cutter, and I wonder if there's a way to create a little mechanism such that you could get this thing somehow, this piece here, to rotate under, kind of like an excavator, when you push down on the top. And I'll give some thought to how to do that. It's that, just thinking that through probably would take 10 or 15 minutes to think about how to do that, but that's an example of combining the notion of the excavator head with the notion of pushing in order to get this to work. So now I've taken some time to think about some of those, and I've articulated 4 of them as little more nicely done sketches. And so this is an example of the end product of that kind of process. So to illustrate the push shovel, if you can get a little sliding mechanism here such that when I push down on this thing, the scoop first makes contact with the ice cream, but then as you push further, it forces, through this little connection here, it forces a rotation of the scooper in order to cut a scoop through a pushing action, which seems like it might be a lot better than what normally happens with the wrist. Now, let me just point out this one here. This idea actually didn't come from the functional decomposition. It came from thinking about kind of one of the pain points, which is the wrist torque that's applied when you scoop. The wrist brace idea is simply you have that brace come up over the wrist to relieve the torque on the user. This is a resolution, and I thought about how to draw it a little more clearly, of the punch and twist idea. The idea is you push, the sharp cutter punches a cylinder, but then you use your thumb here to rotate that cylinder, and it has kind of a diagonal opening to it so that that edge cuts a plug as you rotate it. And then this is a resolution, or a little nicer illustration of how that claw puller cutter might work. And then one additional idea on the pull and scrape is that you might even be able to make it so it had a little hinge or something, so you maybe could even use it in two modes. You could use it in kind of conventional scoop mode, and you could rotate it down so that you could pull and scrape with the scraping action more in line with where it is you're pulling with your hand. All right, so those are illustrations of how it is that you take a functional decomposition, use it to get some insights for what the elements of the design might be, and then combine them in order to create integrated solutions.